Okay, so I want to talk about side-angle-side congruence. Before talking about that, though, I want to show you an interesting situation. Let's say you're given two side lengths and an angle, but it's not an included angle. So that's what this situation represents here. You have line AB, you have segment AC, which is fixed, and this is a fixed angle between segment AC and line AB. And that's all you know. So how many triangles can you make if you have this other segment that's fixed as well? Well, let me see. You can see right here. See, this makes a triangle. And so the situation is this length is fixed here, which is length CB. Length CA is fixed, and angle A is fixed. The thing is, you can also make another triangle for this situation. Like that. This is triangle ACD. And you can see that angle A has the same measure, segment AC has the same measure, and segment CD now it's called has the same measure as the other segment, segment CB. So for this situation where the angle is not included with the sides, there are two possible triangles you can make. Okay. So now let's look at this situation. What if the angle is included with the sides? So here, let's say you have A, B, C. How many different ways can you make a triangle from here? If this angle is fixed and these two segments measures are fixed. Well, so that means you can't move any of this. So how do you make a triangle? The only way is to connect points A and C. Like that. So any triangle you try and make with this given information, if you have AB, let's say this is 3 inches, and BC is 4 inches, and this is 45 degrees. If you have that given information, any triangle with this included angle on these two sides is going to be congruent to triangle ABC. So that's why you can have a side-angle-side congruence, because if you have this given information, any triangle you would make would be congruent to this guy here. So let me show you how to do a construction. Now what I'm going to do here, see I have a triangle that's already been created. I'm going to use a side-angle-side construction to make sure that the triangle will be congruent. So first thing I'm going to do is copy the segment. And make this point A. So that's going to be my second point, B. And as I'm doing these, you want to go ahead and do them on your own as well. And I'm going to copy angle O to angle A. And this pencil doesn't write very well in the transparency, so I'm going to use a marker to mark where the pencil would be. So it would intersect here and here. Okay. Now I'm going to measure the the distance between the two marks over here to finish copying the angle. And then I'm going to apply that here to angle A. Okay, now let me verify. Okay, notice that is a little bit off, and that must be due to some user error on my part. Maybe I didn't get the marker in exactly the right spot. You can see here, right here, this marker is actually a little bit higher. It's amazing how just a little difference makes a big difference in your construction. So this should have been down here. Okay, so I spent a couple minutes looking at my construction carefully. I found when I made my mark, I didn't quite measure accurately with the compass as far as where this pointy end was at the intersection of the arc and with this ray AB that I have here. So that point being a little off, by only say ½ millimeter, was enough to throw off this angle just a tiny bit. So I went ahead and fixed that. I carefully put the pointy end of my compass down, made a mark again, and then drew my new ray. Just really illustrates how careful you have to be when you're doing these constructions. Okay, now I'm going to copy segment OX for my other side in the side angle side congruence. Okay, that's looking good. And we'll call that point C. Alright, so I have a side angle side. I have, let me erase this. I have segment AB, I have segment AC, I have angle A. And from there's only one triangle that can be drawn, and that's by connecting points B and C. Like that. Okay, now these two triangles are congruent. In the next video, I'll show you how to map the congruency between these two triangles.